Hello guys, this is Darsh Kumar signing in into my YouTube channel, and today I'll be talking about determinant of a matrix. So let me start by telling you about what actually is determinants. So in maths, the determinant is a scalar value that is a function of the entries of a square matrix. It allows characterizing some properties of the matrix and the linear map represented by the matrix. It must be kept in mind that the determinant can be calculated only for a square matrix. Determinant is also used to calculate the inverse of a given matrix as well as to solve the linear equations. It is represented by this symbol as you can see here, which basically means the determinant of a matrix A. So suppose if a matrix A is given, then the symbol for its determinant would be this. Now let's talk about some properties of the determinants. So the first property of determinant is that if a determinant is evaluated across any rows or column of a given matrix, the value of the determinant remains same. Second property is that if all the elements of a row or a column are 0, then the value of the determinant is 0. The third property is that if the determinant of an identity matrix is always 1. The fourth property is that if the rows and columns are interchanged, the value of the determinants remains unchanged. So in simple words, we can say that the determinant of a transpose of a given matrix would be equal to the determinant of a matrix given originally. Fifth property is that if all the elements of a rows or a column of a determinant of a matrix are multiplied with some scalar number, say k, then the value of the new determinant would be k times the given determinant. This also has been explained with the help of an example here, as you can see. The sixth property is that if any two rows or columns in a matrix are identical to each other, then the value of the determinant becomes 0. So suppose if one row has, if all the elements of the rows are 1 1 1 and also the second row has the same elements, then the determinant would be 0. The seventh property is that if there are two matrices, suppose A and B, then the determinant of the matrix AB would be the product of determinant of A as well as the determinant of B. The eighth property of determinant is that the determinant of inverse of a matrix can be defined as A to the power minus 1 equal to 1 divided by determinant of A. The ninth property is that in a determinant, each element in any row or column consists of the sum of two terms. Then the determinant can be expressed as the sum of determinants of the same order. The 10th property is that suppose if B is obtained by adding C times a row of a matrix A to a different row, the determinant B is equal to determinant A. The 11th property is that in a determinant, the sum of the product of the elements of any row or column with the cofactor of the corresponding elements of any other row or column is always 0. And the 11th property is that suppose an eigenvalue of a square matrix A is given, then the value of its determinant would be the product of all the eigenvalues. Now let's talk about some of the applications of determinants. So determinants can be used to solve the linear equations, both 2 or 3 variables. Determinant is one of the useful tool to check whether the given system is a consistent or is inconsistent. It can be used to check whether the given linear equation is consistent or inconsistent. The third application is that determinant is used in Cramer's rule to solve a given system of linear equation. I have also included this at the end of the video. You can check that out. The fourth application is that the determinant can be used to obtain the matrix if its inverse is given. The Fifth application is that the determinant is used in the digital images that we see. So the pixels, the group of pixels are represented in a determinant form. And the last but not least, the determinant is used to plot graph and in statistics it is also used in statistics and doing scientific studies and research in almost all the fields. Now I'll tell you about how the determinant is calculated for a 2 by 2 matrix. So suppose this is a matrix B, has values 4, 6, 3 and 8. So here in general we write A, B, C, D in the matrix. So here A is equal to 4, B is equal to 6, C is equal to 3 and D is equal to 8. So for a 2 by 2 matrix, what we do is that in general the formula is AD minus BC. So here by putting the values of ABCD we get 4 times 8 minus 6 times 3. So that would be 32 minus 18 equal to 14. So the determinant of this matrix is 14. Now let's see how to calculate the determinant of a 3 by 3 matrix. So as you can see, this is the general formula for calculating the 3 by 3 matrix, determinant of a 3 by 3 matrix. So what we do is we take this A and then we do not consider this column, the first column and the first row, and we take this 2 by 2 matrix and find out the determinant. Like this we do minus B, then we forget this second column and the first row, and then we find out the take this 2 by 2 matrix DI minus FG. And similarly for the third is C, we forget the third column and the first row, and we take this 2 by 2 matrix which is DH minus EG. We find out the determinant, perform all the arithmetic operation and we get the determinant. So this has been explained with an example. As you can see here, suppose this is a matrix C. Here if we take 6, then this would be the 2 by 2 matrix for it. So 2 minus 2 times 7 minus 5 times 8. Similarly for this we do minus 1, ignore the second column and the first row. We get the 2 by 2 matrix as 4 times 7 minus 5 times 2, and by taking this one we ignore the third column and the first row. We get a 2 by 2 matrix here which is 4 times 8 minus 2 times 2. We perform all the arithmetic operation and we get minus 306 as the answer. So the determinant of this matrix C is minus 306. All these has been explained with an example as well you can check it out I've explained it in the video. So now let's see how to calculate determinant for a 4 times 4 matrix and higher. Like suppose there is a 5 times 5 matrix, we can also use the same formula. So here what we have done is that suppose this is a 4 by 4 matrix. So if we take the element A, then we apply the same rule as we did in 3 by 3 matrix. We ignore the first column and this first row. Take this 3 by 3 matrix and calculate its determinant and multiply it with A. Similarly for this B, here we take as we take B, we ignore the first row and the second column. We get a 3 by 3 matrix and calculated determinant and multiplied by B. Similarly we will do for C and D. Perform all the arithmetic operation and we will get the determinant of the given matrix. Now let's see how we can find a determinant for a 2 by 2 matrix. This is an example of a 2 by 2 matrix. So here as I said, let's suppose this is a matrix A whose value is 1, 2, 3, 4. So here the value of A is 1, B is 2, C is 3 and D is 4. By in general formula we write determinant of A is AD minus BC. We put the values of A, B, C, D. We get 1 times 4 minus 2 times 3. That would be 4 minus 6, and the resultant operation after performing our arithmetic operations we get minus 2. So the determinant of matrix A is minus 2. Now suppose this is a 3 by 3 matrix. So suppose here a value of A would be 2 and B would be minus 3. Similarly I have listed them here. So, assume that this is a matrix A. Then writing the general formula for 3 by 3 matrix, would be A times determinant of EI minus FH minus B times determinant of DI minus FG plus C determinant times H minus E times G. Replacing the values of A, B, C, D, E, F, G, performing all the arithmetic operations, we get 49. So it can be said that the determinant of this 3 by 3 matrix is 49. Now let me also explain you about Cramer's rule. So suppose this is a 3 by 3 system linear equation. We have to find out the value of x, y and z. So in Cramer's rule, what we do is we consider dx by d. Here dx, d is normal determinant that we have find out. So here the determinant for this linear equation would be a1, b1, c1. So we take this constant values of all the linear equations and we find the determinant of that. Here what in dx, what will happen is that the given constant values here would be replaced with a1, a2 and a3. So the first column will be replaced by the constant value if we are finding the value of x. Similarly, if we are finding the value of y, the second column would be replaced by the constant values. And for z, third column would be replaced with the constant values. So let's see with the example for it as well. Here we are given a system of linear equation in 3 variables. We have calculated the d. So here d is 1, as you can see here. Dx is, so here as you can see, the first column in the d was 131. Here it is replaced with the constant values, which is 6, minus 5 and 14. In dy, you can see the second column was 1, minus 2, 3 and it is replaced with 6, minus 5, 14. Similarly in dz, the third column was minus 1, 1 and minus 2 and it is replaced with 6, minus 5, 14. The value of dx is minus 3. If we calculate the determinant of this, would be minus 3. For this it would be minus 9 and for this determinant it would be 6. And for this d, the value would be minus 3. So if you want to find out the value of x, we will divide dx by d, which would be minus 3 divided by minus 3 would give us 1. Dy by d would be minus 9 divided by minus 3, which would be give us the value 3. And similarly for dz, for finding the value of z, we will divide dz by d. So we will get 6 divided by minus 3 and we get the value minus 2. So here the value of x, y, z would be 1, 3, minus 2 respectively. So that was all. Thank you for listening.